We're going to talk about direct variation and what's really happening. So here's the formula, y equals kx, and k is positive. So think about if x gets larger, what's going to happen to y? Y gets larger also. How large depends on your constant of proportionality. Now let's solve for k here. Let's divide both sides by x. And we get that k equals y over x. So what does that mean? It means the ratio of x and y, or y and x, is constant. The reason I can switch these for x and y and x is if you solve for x you get y over k, so you can just consider 1 over k as your constant. What does the graph look like? Well, we have y equals a constant times x. That's a linear equation, and its y-intercept is 0. Remember mx plus b? b is 0, this is our slope. So we're going to have a line, a slope k. And we'll just do the first quadrant because these are usually physical quantities and we won't have a negative like time or pressure or cost or whatever. Now inverse variation has the equation y equals k over x, where k is positive. So as x gets larger, we're dividing by a large number, y is going to get smaller. Okay, now let's solve for k. Okay, multiply both sides by x. So we have k equals xy. So this tells us that the product of x and y is constant. If one goes up, the other goes down. Now let's look at the graph. Okay. So when x is really big, y is going to be small. And when x is really small, if you divide by a tiny number, it'll shoot up your y value, or make it really big. And in between, it's this nice curve that looks like that.